Suresh is here.
Not yet.
Let's get started.
Yes.
Yeah. Okay, thank you. Welcome to DMM Group. This is Srigandavalli and Dpn.
Yeah, just stop on.
So today we have full agenda. I think before we get started, note well, this meeting is governed under certain rules and regulations, and those are documented in these RFCs. Please do read them. And some few other things, administrative stuff. Blue sheets, they should be floating around. Please sign them. And please, we need a minute taker, please. Somebody who can volunteer. Somebody who hasn't paid their dues. Folks who have sent presentations in the last minute or after the deadline. Yeah, there are quite a few. So it's
well, then to get to the point out who isn't.
Yeah. Okay. So we need one volunteer, please. Yeah. You have to pay your dues.
I'll take notes, obviously, except for.
Okay, sure. Thank you so much. Thank you.
There will be of low quality. I'm just setting expectations.
Yeah.
Now.
Okay.
There will be low quality.
Yeah. Thank you. And JavaScript. What is that? We also need a JavaScript, please. Somebody who can be on the Java. Oh, thank you so much. All right, and the links to the working group documents are here. All the slides are posted, except for one deck from Satoru-san. That's there's some change. We'll do that posting later, but at least you can see the older version. That's something. So we have a full agenda.
Yeah. I would like everybody to check that both sides of your badge, your name is visible, that you don't have any papers or something stuck in there. Because I'm going to look at it and write down your name when we're speaking at the mic, and I'm not going to be able to do that if you don't have that.
Thank you so much. Yeah. So these are the first, we'll go over the, the agenda is today, we'll start with the working group documents. We'll get the status from each of the authors on the working group documents, and then followed by the maintenance, Ipv6, PMV6 maintenance documents. And then there are a couple of new documents, new proposals on the very interesting proposals on SRv6, forces, and a few other things. We'll review them. So I think to get started, first one on the agenda, we have the FPC document. I think this is Marco or Lai. Yeah.
I know how good it is. Sweet.
Let me open the slide deck. No, it's not.
Got everything up?
Just 1 second.
Hopefully everything's working.
Slides are not getting updated.
Just FPC update.
Yeah.
Yep. Lyle actually just hold on.
Let's understand this. Yeah, presentation is online.
Online, you can use the browser, open online version.
But what is the difference?
And I see your agenda is okay, right?
No, agenda is okay. Just one second.
You close the all comments.
That's a good idea.
Actually, I know we don't have the presentation up, but I know enough I can get started.
Yeah.
In the interest of time, if you don't
yeah,
mind.
yeah, absolutely. Please go ahead. Actually.
All right. So I'm here to talk about the FPC progress and updates. So as you guys have noticed, our last version was version 7, which was actually prior to the last meeting. And we haven't issued an update since then. However, we've been working weekly since Chicago. And then we decided to actually increase the participation to 2 times a week, I think in June, if I recall. And if you recall FPC, we've got a couple of things going on in terms of the forwarding policy. So we have 3 different trees in the aspects, and we decided to, for this next go around in our update, to focus on 2 of the more neglected aspects of the model. Not to mean that we still don't pay attention to mobility, but we wanted to focus on topology and policy. So as far as work items, we kind of go around robin. We try to work on each of the 3 subjects and then run through. So we've been working diligently on topology, and we've finished up the majority of it in terms of notes. We'll be doing a write-up for that in the next month or 2. And then we've did quite a bit of work on site in in Chicago, and it's all a blur. Yes, it's all a blur in Chicago, and we'll be rolling in updates to the policy. So hopefully we've got the slides up. I'll talk about a few other things as well. So just a couple of other updates since then. So we do have an implementation from Verizon. Sprint's open sourced an implementation in January under the Open Daylight project with the FPC update. Verizon has an update. It's only the provisioning model that's actually in the M-Cord release, and that was demoed at Mobile World Congress. So so a couple other items. No bugs have been filed. We do have some work also going on with internships at a couple of different companies, and I'll talk about some of that work as well. So there's active coding on this with 2 separate projects, both of them open source, one ONOS based in M-Cord, one of them in Open Daylight. And then I get to be one of those few that get to torture interns with a lot of this stuff as well. So next slide. So we have already talked about this. Both of them are based off the version 4. So just as a reminder, we did 5, 6, and 7 in very rapid succession. They had to do with actually errors and updates prior to Chicago. So there's not a lot other than model corrections in a lot of those updates post version 4. Next slide. So this is what I was talking about with the transition. So we do have the 3, we think of everything in terms of a tree, but really 3 areas. So mobility, policy, and topology. We are multi-tenant. Under each tenant, you'll see each of those trees, those really separate pieces of information. And we've been playing the round robin game. We spend, obviously, being DMM, we spend a lot of our time on mobility. We're now focused on finishing up topology, go back to policy, and then finish back again. So a lot of these updates are in here. We'll talk through the updates today, but keep in mind there's no spec out. We'll be sending that out as quickly as we can. So next slide. So just as a reminder, this is the topology slide. So we did change a couple of terms. So we had data plane node, and there was a lot of confusion as to the level of abstraction. So we started introducing the word abstract to be a little bit stronger, so it's a little bit more obvious. Obviously, a DPN can be physical or virtual or abstract. Pick whatever word you like. It can be composite or other items. But we did this because we want to remind people that we're talking about an information model, and so we're really thinking logical. You can interpret that however you like. This gives you an idea, though, basically of how we talk about the physical realization down in the resource plane, as well as what's happening with the abstracted layer in the model that we're operating at. So next slide. So this is a notation. We've seen it before. I think Satoru first introduced it. So just notation's sake, the item on the left is the container structure. You can think of it as the top level of the tree, the top level concept. And then as we go to the right, we're getting into more narrow items. Probably the biggest change that we had was we had a fairly weak typing system. And this doesn't help us in terms of trying to figure out which data plane node we want to select. And so in topology, we've strengthened that concept with Dpn type. So under the topology structure, we have a list of Dpn types. And each type actually has a couple of things. So most notably, the access technology, which allows us to understand what attribute value pairs, what type of terminology they'll be using. The role or function, a lot of people think of these as LMAs or MAGs. And then underneath that, a series of interfaces that are tied with that particular technology and role. And with each interface, we then have a list of protocols and a list of features. And keep in mind, a lot of this is still just the things we need for negotiation to try and figure out if an interface is suitable. And so in the middle of that, we actually discovered a couple of scenarios where the features just weren't good enough. So it was great that we knew, for instance, that it was for an LMA. It was great that we knew the protocol we were after, and it was great that we knew that there were some features. But what we found was some cases, we also needed to know the setting of a particular feature, especially when it wasn't negotiable. So not every particular setting is negotiable, or even if it is, it may be configured so it's no longer negotiable, in which case it's important for us to know that prior to selecting the interface or the data plane node. And so we actually have interface settings, which is an optional structure. So when it's present here, it's really considered a non-negotiable setting as with respect to a feature. And typically, just for example, it's typically when a feature is turned on or off, and can't be negotiated. So this allows us then to look at a particular type in an interface during the selection process, whether that's on an FPC client or agent, and decide whether or not that interface is suitable. So this is the basis of the Dpn type. So next slide. So we go a little bit more, this really just kind of highlights into that what's going on with this, and we give some examples with the technologies. You'll also note we note what's keys. There's also display names, kind of the administrative stuff you would expect for a human readable and type of information model, so what I'll call the usual suspects. What's important about this as well is each one of these keys, so when you take all three keys, the technology, the role, the interface, that compound key allows you to build a reference back to a particular type, and that's what we'll talk about. Next slide. So when we talk about this, we actually have a couple other structures in here. So we have a DPN group list. So as you can tell, there's other DPNs. We have then, and basically this is just a collection of DPNs with a reference list. We also then have DPNs in the structure. So these are that pointers that I was talking about back up to the type. So we should be able to look at a DPN or a DPN group, look at the type, and figure out from the topology information model whether or not a DPN is acceptable. Now, how you then, given several options for a DPN or several alternatives for a DPN that is suitable, how you decide that, that's something we won't go into in the spec. We just want the model to set up the situation so that you know that you have a set of viable DPNs for selection. So next slide. So groups are a little bit more of a harder concept for folks for a couple of reasons. First, groups select multiple types. It's a series of DPNs that we've put together as a collection for a reason. Most notably for operators, this is roaming. So we'll see several functions that we set aside for inbound roaming, and you'll see us set aside several functions for outbound roamers. And really this has to do with routing, security, other things that's important to us as operators. But we want to keep them together as a logical group. So we'll take LMAs and MAGs, and even though they're heterogeneous in terms of their roles, right, we'll put them together and give them this purpose. And so that group concept gives us this. So as a part of that, right, we are essentially referencing viable DPNs in this role, and you'll see that in the structure. And then once again, you see those pointers that I was talking about, back to the interface reference. Also right here, and we talked about the DPN list, this actually made the DPN really straightforward once we kind of got to this design. You see kind of this rinse repeat architecture where basically we're going back to interfaces, references, and the pointers back to the list. So this will give you a pretty basic setup for whether you're going for groups with a purpose or you're actually just scanning across the entire DPN list for a suitable DPN for selection. Next slide. So usage, if you hadn't heard, right, it is about selecting an interface that's suitable and only using the list and the groups. The types are there to determine compatibility. What's important in the spec is we make no assumptions about who's doing this. We want to make sure the information model is available. We do today, for example, see implementations. I know in the open source implementations we actually have clients that go ahead and select the data plane node. And we're experimenting with, in a lot of our other work, where the agent is actually doing more selections. And this just really reflects the code. We built it very top down, you know, the way the network was built, you know, today. And so we had intelligent clients, and now we're moving more toward agents that have a lot more autonomy. So the biggest piece about this is the topology tree is only, I shouldn't say only useful, but it's primarily useful during the DPN selection phase. So the way to think of the topology tree is you use it primarily to select a DPN. Policy is more about applying a lot of the treatments that we want. And then obviously the mobility tree within FPC is more about the individual mobile session. So that gives you an easy idea of how to break apart the model and think about it during our processing stages. So one other note, if you follow triple DS, which is 3598, and that drives a lot of our work in different production networks, the DPN type was intentionally set up so that it produces the same information required to produce simple name pointers compliant to 3598. Next slide. So we actually have worked through Dpn Peering, and what that is, right, is a series of configurations within the groups for individual relationships at the interfaces. We do want to note we support multi-tenancy. I know there's been a lot of talk about slicing. We've always had multi-tenancy in the model, and so we don't bring it up a lot. It's independent of slicing, and we do have some support for slicing as well, although you'll probably hear more about that in subsequent updates. So those are still there. We leave them kind of as open items because obviously the whole work around slicing is still fluid. But I think we have a fairly decent handle on it. And I can tell you just from both of the implementations in the wild, they actually handle at least multi-tenancy quite well. And then there's plans for both implementations with Verizon and Sprint and others to kind of coordinate between the two open source projects about what we want to do with slicing. So as we know more, we'll be informing the group. Next slide. So as I mentioned before, I get the privilege of torturing interns. And so we do this for a couple of reasons. One, there's always too much work. And two, we like to get a wide variety of skill sets to test our actual code as well as our standards. So we looked at two things. So we looked at pre-provisioning a policy. So we're not interested in mobility. We have it working. We know a lot about it. In fact, I think we're kind of getting tired, at least, of coding with it. And we also want to look at a use case of 1+1 availability composite DPNs. And so we had 2 interns that were at the undergraduate level. One had graduated, one only had 3 classes. So not exactly someone you would expect to come into the workforce and code. Both of them have been successful in their implementations. And so I'm quite happy with the results, but it looks like just conceptually, only working with them a few hours a week, they're able to look at FPC as far as the specs, the information model, and get their work done. Composite DPNs, just as a note, M+K, 1+1 configurations, we did the work and we wrote it up. And just for 1+1, we had about 7, we have a professional tech writer on staff. It was about 17 pages explaining the operational concepts. So what I would say is for things like high availability and this sort of stuff, maybe in DMM, what we discovered was very easy to say it might be a good work item, very hard to explain as a standard, and would create really long documents. So our general theory is we're more than happy to share the information and talk about it. But originally we thought we'd be bringing this work into DMM. I don't think it's worth our while because it's very operationally focused. And it's just a lot of information to process and parse. So, so we'll actually probably be talking about that, maybe sending stuff out to the mailing list, but we won't be submitting any sort of new work for DMM in this area. In fact, we think the M+K documentation will be 100 to 200 pages, just operationally describing it. So next slide. So as we talked about in order of appearance, you'll see work on topology. We did a lot of work on policy. We're reviewing that again this week, starting again today. And we'll be back to then updating mobility. Next slide. So we do have some aspirational goals. I never like to say, the second I say goals or these are the objectives or this is the date, we always fail. So aspirationally, we would like to actually get a lot of this updated in the same spec prior to 99 in the next couple of months. Or excuse me, I'm sorry, prior to 100 in the next couple of months, and not at deadline. We'd like to get it out to the point that people can review prior to 100. And this is really dependent on you guys. The more reviewers we have prior to 100, the more likely we'll push you know, leadership to a last call or something to that effect in 100. Yes.
Suresh Krishnan, AD. So one of the things I want to say is like so you said deadline, so how far before the deadline are we talking about? Because practically speaking, right, so once you have this ready, as I talked to you before, like I want to get the somebody from ops to look at the data models and stuff, right? So as a practical matter, right, if like 3 weeks before the IETF I go to them with a review request, it's not going to happen. Yeah. So the earlier that you do it, it's better. So I would say like shoot for some time in September.
Yeah, I try latest end of September. Anything in October is just
it's not going to work,
it's
right?
not
Like
quite.
We won't get the review before like we do the working group last call, right? Like, and that's okay with me. So like, but as I explained before, the earlier we catch something, the lesser the delay it causes.
Absolutely.
Okay, so really try to shoot for September.
Okay.
Thanks.
Yeah. All right.
Thanks, Suresh.
But we can't set a date. We'll automatically fail. That obviously, no, I'm just kidding. I think I'm superstitious.
That's okay. Like, just keep it in your mind, and we're not putting a milestone here, right? And if you notice in IETF, the milestones are already aspirational dates.
Yeah.
Anyway, so.
Right.
Yeah.
So Suresh, you will assign the reviewers after the I'll send it to after the 08 is published, after the next version is published, and
so whenever like like you and the authors tell me it's ready for somebody to look at from the Yang perspective,
okay,
I will talk to the ops ADs. Like I'll actually talk to Benoit, like and get somebody to just do the Yang stuff, right?
Yep.
And we might get another ops to review like for the operational stuff after. But at least I'll get this done out of the way because this is something like where the interior is not where the expertise is in this. For the mobility it is, but a lot of times like the comments I get for the mobility specs is it's very obscure for a lot of the people outside the area, right? Because like we all have a shared understanding of what's happened in the 10 years and we kind of assume everybody does, but they don't. So I think it's good that we get this done before and not have a last minute surprise. Like,
Yeah.
for example, there's a draft. We just finished IETF last call before the meeting, right? Like probably a couple of weeks ago. And like there's like a serious gap in understanding between us and the rest of the IETF.
And we've already had even with Chicago, right? We already had a run-in on the day of submission when the Yang guys came back and had that.
So do that earlier so we don't get surprised.
yeah, absolutely.
And they don't get surprised.
yeah,
Yeah, and moreover, it's a long document, so it takes some serious efforts.
Yeah. absolutely. Understood.
Thank you.
Right.
So I think maybe more reviewers inside the DMM working group could also be helpful. So may I ask, is there any volunteer to help review this long document? If you volunteer, we can write your name in the meeting minutes. Anyone?
I would advise rather than pinning someone down before a big update.
Okay.
Let's not. I mean, if you want to volunteer now, that's great.
It's
but-
a lot of work.
Yeah.
Suresh Krishnan, sorry, I still have the same badge, Michael. So anyway. I still have the same badge, I said, like I don't change. Without a review, the document is not getting out of the working group, right? So like I really want to see some kind of review, like somebody else other than the authors and chairs reading it. Like that's essential.
And I would invite anyone. They don't have to. You don't have to be an author. We have weekly or twice a week meetings. It's just a call. Anyone that's out there, and I'll send the larger invite out to the group. You're more than welcome to pop in. Just because you pop in once, it doesn't obligate you to be on every call.
No, also we have initiated a few emails, right? Probably as you have seen, one to Prakash and so some domain experts who understand this, right? So we are going to do that, Suresh.
Right, that's fine. So, but one thing I want to point out is like people, other ADs, specifically looking at mailing list activity on this, right? Yeah, like to figure out if there's been enough review. Like I do it, and other people do it. So I do go and look at other working group mailing lists. And a lot of the documents from DMM like have this issue that there's not enough stuff happening on the mailing list. Like a lot of people not reviewing, and I kind of want this to change, right? Because there is like a lot of interest in the room, like there's people here, but if you don't review documents, then if everybody's just writing documents, it's not going to cut it because the documents are not getting the review they deserve. Because like the chats are going to read it because they have to, like I'm going to read it because I have to, right? But other people need to do it voluntarily to actually read stuff, right? So
Absolutely. Thank you.
All right. That's it.
That's it.
Thank
you, Ryan. So what are the next steps, right? Essentially,
we've got them here, right? So we've already talked about that a couple times, right? So this is really this week getting that review of topology, seeing how far it goes. We've got a bunch of write-up internally then to kind of proto the next version for both the topology and policy, and then let's see what the impact is on mobility. That will then allow us to understand if it's a large impact or small impact. Really, that deadline, how far ahead of October 1st do we deliver? And then you'll see us then push out for reviews and everything else. But I expect us to maintain our cadence, which is there will always be 2 calls available. Not everybody shows up. We don't always have quorum, but there's two times a week for an hour where we could discuss this along with the actual discussion via mail. So we can keep this moving.
Okay. Thank you so much. Thank you, Lang.
Thanks.
Thanks, Arthur. Next slide is Charlie Perkins. This is essentially the mobile MN identifier extensions, 4283 extension. So this, just to give an update on this document went to IESG, and essentially IESG issued a discuss on this, and the draft has been sitting but no progress, right? So I requested both Charlie as the lead author and also Suresh Krishnan as the AD to really see if we can discuss this issue here and see how can we make progress. So just 1 second before we move on. Yeah, you can get started, Charlie. I think
So Charlie, do you want me to start off with the opening for this and then you go on?
Well, certainly.
Okay, so what happened is this document went through the IESG, and so it got like a bunch of comments, and they're all centered around security and privacy, pretty much, right? So 2 major items. One of them which says are these things encrypted, and what are the guidance for encrypting them? So what's sensitive, what's not? That's the first question. And second question is like we had like a whole number of MNID types, right? And people say like, okay, are these really needed, right? Like, do you need this many types, and who uses them? And I didn't have an answer to the second one at the time the discussions are done until like yesterday, right? And so I do have the answers to take back to the IESG regarding at least the RFID types, because it was not clear at all what the RFID use case is for the MNIDs. But Halima, like, who was like actually proposing it back then, again, we didn't have a mailing list trail for this, so that made it difficult. I do have that information, so I'm going to post it on a mailing list, like whatever information I got, so it shows up for everybody in the future. Okay, but at least that part of it is clear for me, so I can go and justify it with good conscience, because I couldn't before. Okay, so for the security stuff, I guess Charlie's going to make a proposal.
Okay, thank you. So just a slight bit more context. This draft was sort of like finished, a year ago or more. And then it sort of had last call, and as been noted, we didn't get comments. And so then I think that left Suresh with absolutely no defense when he was talking with other folks in IESG. And at actually getting comments on any document, as already noted this morning, can be problematic. So I didn't particularly view that the same phenomenon was happening for MNIDs to be a serious defect, because it's like the other drafts. But nevertheless, the comments that came back from the IESG certainly did deserve attention. And when we got the comments over the last few months, well, finally, I think we've gotten pretty much possible resolutions for the issues that were raised, and that's why I'm here. And the format of the presentation is a little unusual, because I just copied segments of the mailing list stuff right on the slides for PowerPoints, and I thought, well, it's pretty efficient, and if I can capture the nugget of what was said, then that's less work I have to do otherwise. So next slide, please. So just briefly, there's a lot of types in the draft. They were all put in because of requests from years ago, and then there was a little bit of digestion that occurred, and then a comment was made that we really had to put fuller descriptions in for each one of the types. So that was a lot of work, and then we've had too much description, so we had to pull some back out, and had to be not normative. This is sort of the, you might say, sharpening process for the draft. So I thought by the time we were done, it was pretty sharp. But anyway, here's what's in there. We have the V6 address, and actually that's the one that I'm not quite sure we should have in there. There's MZ identifiers. They could obviously be put to use if someone wanted to create protocols for those devices using mobile IP sort of approaches. IEEE address types for MAC address, and actually this turned out to be really useful if you have some of these like multi-interface or unnumbered interfaces sort of that you wanted to handle somehow with the mobility management. From DHCP, the DUID types, and then I guess what has been, you might say, the major discussion recently was about RFID types, and maybe the reason is because there's so many of them, so they look voluminous in the draft. But so here, oh, I forgot. I thought I turned these into black, but anyway, I've left it. So this what's in red right here was directly added to this slide from Hakima's discussion that we were having back and forth. So she points out that these RFID types were specifically put in there so that you could use mobile IP for tracking work, and would be useful for mobile banking payments. That obviously requires high security, and also, let's see. Well, she has in mind to do some RFID applications so that you can sort of detect motion and location as you're moving around in your with virtual reality on. Just as a side note, about a month ago, I had my first experience for virtual reality, and I didn't want to move. I just wanted to sit there. But anyway, okay, next slide. Oh, also she mentioned that maybe it'd be a good idea to consider yet more ID types, since we're now diving into the LPWAN world of different kinds of identifiers. But I don't propose to do that. So, and Suresh is assuring me that I should not propose. So,
Okay.
next slide, please. Okay, so Vijay wanted to just summarize what Ben Campbell's issue was. And so that's what he had to say. Ben Campbell wanted us to explicitly identify which of the IDs have to be encrypted and not just say that some of them may need to be encrypted. So that's pretty nebulous. Perhaps we could say it depends on the context, which is true, but I'll have more to say about that in a minute. And another option is just to say that they carry an MNID may need to be encrypted over the air for all MNIDs. That might be the safest. And so my answer to that is, I agree. I'm okay with doing that. Next slide, please. So Vijay was discussing Stephen Farrell's discuss. He seems to be saying that the privacy concerns need to be explicitly justified. And Vijay points out that there are privacy concerns with every kind of mobile node ID. And so the user can be tracked using that under many kinds of the mobile MNIDs, and even the ones that are currently standardized, you could be easily tracked. And so it doesn't too much matter what kind of MNID you might be using. It still could be useful for tracking if it's really a close identifier. And this might be related to some things going on in this IDEAS discussion this afternoon. But again, that's way future, and this is present. So so I believe that observation from Vijay also justifies that we must encrypt the contents, because we're operating at the network layer and we can't know what the application is, which means that we can't determine enough context at the network layer, or we shouldn't be able to unless we have serious layer violation. But we shouldn't be able to determine whether or not the context requires encryption. And so if you're going to do this, you should, I think we should specify encryption. And Hakima enlarges on that. And I believe that her comment here should be taken in the context of, well, what if we don't encrypt? Well, then she's proposing another possible solution whereby you could actually ensure privacy by some sort of operation, sort of, you might say, massaging the actual mobile node ID. So next slide, please. Okay. So then there was, this is intended to be addressing the point about, well, why do we have all these MNIDs? And so the reason why we have them is because people asked for them, but people didn't, you might say, continue to ask for them month after month, and so that led to the perception that they really didn't want them that bad. And so so then we had this recent discussion about, well, which ones do we really want and how to justify those. But I also would like to point out that this is not a new protocol. This is a registry, and the downside of including possibly useful identifier types in a registry is not catastrophic. It just means maybe people won't use it. And so I've given, just as an example, this particular draft as a case in point. How many years have we had this? 2 years? Well, if somebody else wants to register a new kind of type, and we could foresee that that would be useful at this point in time, well, why do we make them go through another 1.5 year cycle for a new draft that has difficulty going through getting enough comments on the mailing list? So my point here is, it's not too hard to figure out that these are going to be useful mobile node identifier types, and it is pretty hard to get the drafts approved and so on because of the operational and the procedures. So so then Suresh says, well, no problem, but actually really what's going on is what's in these parentheses, assuming proper security measures are taken. Well, true enough. And so that's what we are proposing, is that we should take proper security measures that can be applied at the network layer without knowledge of context, and that means encrypt. So next slide, please. Okay, now let's see what's going on here. Right, so this is, I guess you would say, I already said most of this, I'll just point out. So this is an argument that we really, we could have in the past entertained additional protocol designs that would have been facilitated by the availability of some new kinds of mobile node IDs besides NAI. And so Suresh says, the issue is that nobody's coming forward to say that we want them. Well, this is related to the known phenomenon of quietness on the mailing list. And Hakima is, I could read this to you, but or you can take a look at the slides. But basically, it has to do with the fact that we're going to be dealing with mobility and Internet of Things. And the point of the Internet is to consider a lot of kinds of communicating devices, and particularly sensors and RFID things and so on. So what else should I say about her comment? Right, so mentioning about, separating the identifier from the address. So this, if you think of a mobile node identifier as well, the mobile IP uses identifier as a locator as well, but we should be able to use other kinds of identifiers in the process and then do the location as well. Oh, comment or question?
Yeah, so this is something I just want to float, okay? So to the working group, think about this. Because one of the things you said is oh, it's all difficult and do a lot of work in the future and so on, right? So I have a amelioration for that. So make this registry, change it to expert review, okay? Which means that somebody doesn't have to write a document through this to get an ID, and I can pick somebody who's participant in the working group for designated expert, a couple of them, and then somebody who comes in the future and says I want Sigfox IDs, they don't have to write a draft and take it to the working group. So that's something I can do.
Okay.
So so if that's something the working group wants to pursue, we can put it in here, right? And I might need to redo the IESG balloting if we change the IANA policy, but I don't mind doing that, rather than going through another last call.
Okay, but I think if we do that, we should also include a note in the IANA instructions that basically says the expert should consider certain things.
That's fine. We can do that thing, right? And I will take it up with IANA. So if the stuff changes, I will let the IANA know, because I need to put in the designated expert, right? In there. So I need to nominate them, and the IESG needs to approve, right? So that's a given, but it's just something for the working group to consider. So because I don't want bloat in this, for potential applications, right? That's the idea. So because people say it's difficult to get new IDs, so I'll put all the things in, right? And to balance that with, a need for doing less future work, right? So.
Right.
And the expert review is the line that helps you do both.
But this is with the assumption that the current text and the registered identifiers in the draft will stay only for the newer types, right? Okay.
Yeah,
that's perfect.
Right, so whatever comes in the future, because I don't want to throw in another bunch of things in there, you suggested, right? It's a good idea, right? But that means I'm going to have to take the draft through everything again, right? Working group last call, IETF last call, balloting, and everything, right? So if you add new types in here, but if you change the IANA policy, it's a policy change for me that I need to take through the IESG. So I can put the draft back on in front of the IESG, tell the IANA that the IANA policy, we want to change the IANA policy, and these are the designated experts, and we are done. Right?
Yeah, that I'm happy with going through last call again and the proper operational ways of noticing what the IESG has to do. And if there are more changes that are needed, okay, no problem.
Sounds good.
I just want to see forward progress.
Okay.
Okay. Next slide.
Next slide. Right. So maybe I already said all of this sort of thing. What else should I say? Yeah, I think I already said all these things. The next slide, please. And I wanted to show Hakima's work that she is doing and searching for funding and getting some programming done and so on. But it's some cool work, and you might take a look. So if you have, get to the slides and take a look at these URLs, you can see what's going on with this track IoT work.
Okay.
Next steps, well, here I am, making sure that the issue resolutions are satisfactory. Proposal is to make encryption mandatory. That solves the privacy and other issues. And under this circumstance, it's, I believe, fine to keep the existing MNID types, make further revisions, for instance, INR considerations or whatever else is decided, and finish last call.
Okay, so we can achieve this in the next few weeks, Charlie, or what is the timeline for this?
You know, I don't have a hard requirement. Whenever it's if somebody sends me an email that I got to do something, I'll do it, and I'll be responsive until about the end of August, in which case it'll take a little longer.
Sure. Okay. So that works, Suresh, from timeline. Okay. Thank you.
Okay.
So any questions for Charlie on this? No. Thank you so much, Charlie.
All right. Thank you very much.
Thank you, Suresh. So next we have distributed mobility anchoring. This is Anthony Chain. Okay. PPT is not sure. PDF is there. Yeah, Anthony. Right.
So this presentation is to update the reviews we have and the changes made. In the next slide, we had version 3 last time, and a number of people have agreed to review the document. So we had received the review at different times, and we try to update that as soon as we receive the review, shortly after review. So it goes from version 3 to version 4 after review, and 2 additional review go to version 5, and then another review go to version 6. And Marco's review is coming, but that's what I'm hearing. So I'm going to go through what are the changes from each review. I'm not going to list all the review comments, but just mention what are the changes in those comments. So in the next slide, from version 3 to version 4, in the next slide, there were a lot of editing suggestions, and then they were all taken. And besides that, the comment was to expand the security section to elaborate more. So that was done.
So Anthony, just to make sure I understand, so the 04 has addressed all the comments from Dirk, Baiju, Eric, Carlos, and Marco? Marco hasn't provided
version 4 only from the... so if you go to... Yeah, that's
this is the one.
From version 3 to version 4 is in between the comments.
Okay. Okay, I think the critical comments are mainly from Carlos, right? Essentially, he had some major issues, right? So 04 has addressed those comments or no?
Not yet. It's only...
version 06.
Yeah.
Okay.
Version 6 good.
Okay.
And then after that, there will be the comments from 2 of those. So the next slide would be there are a lot of editing changes. Well, I'm not going to mention all of them. And Parade had comment about the network slice, either mention what it is or delete it. So the choice was to add the reference at that time. And then the other comment was that it was a very long document, 50 some pages for informational document. So I tried to condense some of them. So it shortened a little bit, still 40 something. And after that, so the next slide would be Carlos' comments. And this time we deleted the network slicing entirely, so it was gone, including reference gone. There's no need to get into it. And And another comment, there are lots of editing comments I'm not going to mention. I'm only going to go, no.
Yeah, I think the key thing what you may want to talk is like, what are the key issues that are raised, right? I think editorial minor things, it's okay, no big deal, right? But
The
many
list here
technical
are
issues.
not the other issues, okay, not the minor one. And he doesn't want to have the defined security management entity, which I agree. I just describe what it does. And then figure 1 was difficult to understand, so I'm going to mention that later in a different slide. And then one key issue was that the change of the floating table is a controversial. Is still controversial. There are security issues and there are scalability issues. So I removed the description of that part and leave it to the actual solution themselves to do it. And then there are also the state, not getting the state, not going to the optimization of mobile networking. So I deleted that part. And also added some references which are missing. And then I'm going to go through some of the issues. The next slide is that the comment was that is this draft for proposing a solution or not? And the answer is no, it is not proposing a solution. Then what it is basically describing the mobility anchor and what are the parameters being exchanged. It will be clear later when I go through the different sections, okay, and then give examples for doing that. So and that sentence was there in the description, but but was not spelled earlier. So I moved it earlier and moved some of the text to make that make the scope of that more clear. And then let's go to the table of content to see how that scope works in the next slide. So in section 3, we already had an architecture job to define the control panel anchor, data panel, control panel, and so on with that, okay? But then, so this is going to do further, what are the functions that are, in terms of what are the functions that are going there and what those functions are. So in section 3.1, where those functions are, in which anchor are those functions and so on, which node. And then what are, and this is specific on distributed anchoring because the key point here is that you don't want to be a centralized anchor. You want to be able to move the anchor. So if I had a distributed anchor, what are the functions that you need over there? Now that is a very long list of functions, and it was clarified initially that you don't need all of them, okay? Because the solution, there's many different solutions. You can do tunneling, you can do some command to change the routing, you can do many other sessions in the. So that was intended to be what are the different functions that you can put over there. And it turns out that you don't need all of them. It depends on what solution. The solution may only need some of them, so you don't need to implement all of them. And then with those functions, what are the operations of those functions and what are the parameter is going to do. It breaks that into you have the location, you have the floating management. Okay, and with that, that description of the anchoring, because distributed anchoring is new in the sense that this is not a centralized anchoring, but you still need a lot of the function that you had before with the central anchoring. But what else do you need? So it's a description of those functions, and that was basically the description. And now after that description, what are you going to do with it? And the next step would be a solution. But this job is not trying to propose any specific solution because you can go to other job to look at the different solutions. This is the informational job. So it's giving an example of how to put the solution together without going into the detail of what the steps going on. There are comments that this is a long document, but for people using it, you really don't need to read through all of them. It gives a very elaborate example of the different function. For example, in section 4, you start with distributed anchoring. First of all, if you don't need to change, keep the original address, you can just use a new address, and that is an acceptable mode for DMM. So that description was in section 4.1. But if you do need to change the IP address, then you have to change it. And if you do need to change it, then in section 5 is describing examples that try to have different way. 5.1 would be a flat network, so you only have the anchor and then go to the node. And then and then you move the anchor, and then you introduce the hierarchical network. Besides the anchor, you have the node down there, and then you switch the anchor, switch the node, and then and then you also had a scenario in which you do the network mobility. So there are different applications that you had. So for the reader, you don't have to read all of them. Basically, for example, if you just have a flat network, you can stop in 5.1 and be happy with that. And so that's an example of the try to give example of the different application area. That's why the document seems to be quite long in that sense, because it's more like a guideline on to put the solution together. Okay, so that clarifies the scope of the document, and it also clarifies how to read it. Basically, you don't have to read through the whole thing depending on what you're interested in, what you need. Okay. And then another major comment was that the figure was very difficult to understand. So on the left-hand side is the figure 1 in version 5 and figure 1 in version 6. On the left-hand side, just put down, basically trying to say you had the anchor, you had the control plane, the data plane, and then what are the functions you add onto it. And what we are adding are the location, the information piece, and also the forwarding function. These two functions also separate into control and data plane that we're putting in. So on the right-hand side is the figure 1 to make it more clear. So we draw a network, and in that network you have control plane function, and you have data plane function. So there's a separation of control plane and data plane, and it also shows that the data plane is distributed. So that's the architecture of the network and what the function you put down there. And separately, you had the location function. So in the location function, it calls there's a location such as a server, client server, okay, that you are communicating with each other. And then the node, the mobile node at the bottom is just a mobile node attached to the network. So that was trying to explain the figure to be more intuitive. Okay. Now, after explaining figure 1, then the rest of the figure, I'm not going to redraw the whole network, redraw everything, but just put a block anyway. But they are revised a little bit to make the figures more clear. Is that all? Is there? The next one is, so for example, in the rest of the figure, I'm not going to draw that whole figure as figure 1 in that manner, but just put down you had the same control plane, and in the flat network you had two data plane anchor. So you move the control plane, tell them to move. Okay, and there are other examples, but we don't have to.
Okay. Yeah. So is that all, Anthony?
I think he wants to read through it.
Yeah, I think we want to make sure first thing, editorial issues are okay, but technical issues, first thing, step 1, we want to make sure there are no technical issues with the draft. Okay, we don't want to send the document to go to ISG and come back. That's goal 1, right? Yes. Then editorially it should be readable, right? If somebody cannot understand it, there's a problem, right? I think all the 4 people who have reviewed it, I want to make sure we want to make sure they sign off, whatever sign off the changes, right? I think that's the key thing, right? So Carlos and whoever signed up, if you can please review it again, and if you're okay, say the same thing, and we move on.
Let me see if they're in the room. They're all in the room.
Sorry,
but not all the reviewers in the room now.
Okay, that's fine. I think we can post the minutes in to the mailer, and we can ask the reviewers. Yeah.
The reviewer have been very helpful, not just with the critical part, and I want to thank all the reviewers.
Okay.
Thank you.
Thank you, Anthony. So before we move to the next presentation, blue sheets, please. Can you everybody please make sure you sign the blue sheets? So next we have, so this is on-demand mobility management socket extensions by Danny Moses. Just, so this is a working group document on socket extensions, and Danny will give an update. Yeah.
Thank you. Next slide, please. Okay, so in the last face-to-face in Chicago, there was some discussion about the nature of blocking of set socket opt. I was told that I'm not allowed to do that. It's not a good thing. And I was requested by the chairs to come with some alternatives for a resolution of that problem. I'll describe that in a moment. And another small addition I added to the spec is a new session continuity type called, we called it Graceful Replacement. It's really to be similar to SSC Mode 3 in release 15. I thought for a while whether I want to add that or not, because it's good to be to follow, in some cases, ideas from other SDOs, but I wasn't sure that it's appropriate in this case. And finally, I decided that it is, and I'll explain why when I get to that slide. So next slide, please. Okay, so the blocking function, setSockOpt could block if the application requests a session type, and as a result, the stack needs to communicate with the network to request this specific IP address, and we were told that's not good. And as a result, we wanted to find some alternatives. Next slide, please. Okay, so we came up with 3 alternatives. We posted them on the list, hoping to get some feedback or some people who would say what they prefer. We didn't get any feedback.
Right. I think the question is also about the expertise, right? I think many people may not be, experts in this socket,
Okay, no,
socket area.
I'm not
So,
complaining.
yeah, right.
Just-
On this
I'm
one,
just-
yeah.
okay. So I'm just saying, we gave people in the list a chance
Right.
to comment. We didn't get any comments. Just a minute, Dave. And we chose one of them. So I'll describe all 3, and then I'll describe what we chose. Dave, you want to say something?
I thought I commented.
Yes. Was it on the list or privately with me? I think it was privately with me, and my understanding of your comment was not, you didn't select one of the 3. You just said, I don't think this work is necessary. So it's not a response to one of these alternatives.
Yeah, if the same discussion can be forwarded to the mailer, it will greatly help, like as Suresh was saying
okay.
earlier.
Yeah, we weren't aware of that. Okay, so the first alternative was practically described in the session in Chicago, and that is you cannot block setSockOpt, so add another function that does the blocking. That was alternative number 1. I must say that originally we tried, and I'm talking about Alper's original intent, we tried not to define a new function because we thought that would be too difficult for people to accept. And it would be much easier to say, hey, we're just adding another field, but not a new function. But after that discussion, we got to the conclusion that we can't avoid that. We'll have to add another function. So that was alternative number 1. And then we came back home and said, wait a minute. Why do we need 2 functions? If we are blocking and if we're adding a new function, let's just not change setSocket options, but add a new function that requests a service. And that function can block until the service is provided. And it will be provided by providing back an IP address. And the application can then bind to this IP address. And that's basically is the solution, the second alternative. And the third alternative is quite similar, but we were saying, why request the application to bind, this new function can implicitly bind the socket with a new address, and then we save a call. So these are the three alternatives. Next slide, please. So this is a more detailed description of alternative one, call set socket option. The call will may trigger some action with the network, but it will not block. Call a new function. We called it wait for service, and that will block until we get the IP address that we were expecting. So that's, next slide, that's alternative one. That's a code sequence if someone is, if it helps people to understand. And it works, but as I said before, but wait a minute, why do we need set socket options? We can call wait for service without that. So the next alternative, next slide, says, okay, we will define a new function, set session continuity, in which the application will request the type of session continuity it wants, and set SC will return with an IP address, and then we will bind to that IP address. So can we see the next slide? This is the code sequence. We open a socket, we call sets SC. When we get the address, we call bind and then connect, and we're all set. So no problem with set socket options. Third alternative is very similar. Jump to the next, no, the next code sequence slide. Next one. Next, exactly. So it's very similar to the first one. I grayed out the call to bind because set SC will implicitly bind to that selected address. So these are the three alternatives. And next slide. We were waiting for feedback. We didn't receive feedback. I think I even sent a reminder. We didn't get feedback. So we wanted to make a decision just to not to have to wait for another face-to-face. We thought the second alternative is the most appropriate one because it follows the behavior of the socket API, and this is what we chose.
So this issue was raised by Eric, right?
By Eric and by the Google guys.
Yeah. So
And Lorenzo.
Eric, any feedback on this? Primarily, this issue you guys raised it. Are you satisfied with the solution? Is he in the room? Yeah.
Yeah.
Long, slow walk. Sorry, Eric Klein. Can you go back to the slide with the alternatives, of which this is the second?
Is that one right?
Do you want to see the code sequence of the second alternative?
Yes, please. Which is
This one, yeah.
what's the guarantee when set SC returns? Is that IP address? If it returns, if there's no error, assuming there's no error.
Exactly.
That IP address,
if there's no error, that means that the stack had communicated with the network, requested a prefix, received a prefix, and created an IP address with the specific session type that was requested. Otherwise, an error will be returned.
Right. And the return type is, it will return like a socket or storage or something?
Yes.
And it looks up an address. The parameters that it takes are, it knows what family, or it's V6 only?
Yeah, again?
Is it V6 only? Or is
yes,
it knows
V6 only.
Okay, it's only V6 we're worried about. Okay. As long as that function is documented to that this blocks, right?
Yes.
Then then that seems fine to me. Like for POSIX kind of people, you might want to have an async version, or like,
okay,
call me back with a completion when this is done, so that you could write
Yeah, I understand that.
A non-blocking version?
Yeah, I accept that. I just want to remind you that we are not defining actual APIs.
Right.
We are defining concepts.
Yes.
So later on, people can use that as guidance when they define the actual APIs in different languages. And
Yeah.
so on.
Yeah, I understand. Yeah, but okay. So yeah, if it makes sense, right? There's a documented blocking call version, and there's hopefully we can request that people implement an asynchronous version as well. That makes sense. How one gets notification in various operating systems is a different and tricky matter.
Specific, yeah.
Yeah, it seems fine. A separate call that's documented to say this can block for an unknown amount of time and might fail when it's done.
Right. Okay, thank you.
Thank you, Eric.
Suresh Krishnan, so Eric, that's a good idea, but like that means like you need another abstract function, right? That's the notification function, right?
Yes.
So just
it depends on your operating system. It depends on your operating system. You could imagine tickling the file descriptor, saying that it's readable when it's, although maybe reusing the same file descriptor is a bad idea.
So I accept the idea. I don't want to add another function because I'm leaving that to the specific implementation in different programming languages because they are different in that case, and I don't think it should be here.
Yeah, they're the same logical function, right?
Right.
Just one is blocking inline and one is
Right.
asynchronous.
Lorenzo Colletti, in general, bind is really hard to use because it requires one IP address, and you can only use that, and you can only bind if you know what IP family that you're trying to connect to.
Yes, but setSC returns this IP address that you're going to use.
But
Yeah.
you don't know the address family of the destination that you're connecting to yet, or you do? We're writing V6 only
Yeah.
code.
Yeah.
I don't ever want to support anything else.
This is the charter of DMM.
I see. Okay. But there can be more than one V6 address with these properties. So who makes that decision? setSC or?
setSC will return with one IP address.
Right. And if the application wants to make a different choice between the two, for example, use two different PVDs or whatever, then setSC has to take those parameters. It has to know about that. I mean, another approach would be to say, just set the address preferences like we have now, and just say, I want an address of this form, right? So what you want is you want to say to the network, hey, give me an address that looks like this, and get a callback when something arrives. Maybe you already have one, in which case you get called back immediately, and maybe you don't, right? And then you say, well, I said, bind is usually not a good idea, but like you basically, and you say, look, set something on the socket that says only use an address of this type, and then call connect. And then if you don't have an address of that type or whatever, you can get add or not avail. And if you want to do something more complicated, you can always call bind yourself.
Right.
Thank you, Lorenzo.
Yeah, I have one comment, Danny.
Yes.
Does this mechanism, like you mentioned in slides, called setSC function, does that allow, for example, multiple interfaces? For example, one node require multiple IP addresses.
Multiple, you mean multiple, are you talking about multi-homing or?
Multiple IP addresses for one node.
It doesn't contradict having multiple IP addresses for one node, but SC will return with one IP address, and that's the IP address that was selected for that application, or for actually for that socket. Yeah.
Michael Abramson. So I was going to ask about the whole API, and this is you said we don't standardize APIs here, and this is abstract. That is not perfectly clear from the text, the initial. Like if I read the introduction and so on, perhaps it would be good to make an explicit statement, just basically saying what you just said.
I don't mind doing that, but this draft is not different than any socket API related draft. We have several socket API related drafts, and they are all the same.
Okay.
In fact,
considering what Dave Thaler said the other day, perhaps we should start saying that.
if there's something that normative that we want to add to all these drafts, I will add that.
So Krishnan, so what Dave specifically said is we don't do any language bindings, right? And so this does not have any language bindings, and it's pretty abstract at this point. And like Danny said, like we want to kind of keep it that way at this point. But and we haven't really figured out like how to interact with all these other bodies, the Austin group kind of thing. So it's very, very informal. So like if this goes through like further, like and comes to me, like I'll go to Dave Taylor to like, you know, kind of socialize this at some point. But we haven't figured out an official way of doing this. And I don't know if we ever will because of the IPR policies and things like that, right? So, but as long as it stays abstract, we've done this before, staying abstract. We tried that in MIF too. It just didn't work out at the end. But that's the goal. Goal is to specify the abstract functions and then go from there after.
Okay, so it's just that to me, this doesn't look that abstract. This looks almost like C code. So, okay, sure, fine. But it's like it's using what someone would basically put in C code.
So Michael, at some point I got a comment in the working group to add code samples, and what I did before adding the code samples is I checked previous RFCs to see if they have code samples, and they had code samples, so I felt good.
So I'm not blaming you.
But actually, the code samples won't. I can guarantee that they will compile. Okay, it's again, and that was just to.
But okay.
Lylebert, so maybe your suggestion here, right, is to be a bit more prescriptive about the fact that this isn't a language binding. It's more. Yeah. So would the elegant out here be anywhere you use the word code to just say pseudocode and leave it at that?
Yeah. Yeah.
Would that work?
Yeah.
All right.
Okay.
Thanks.
Because that makes it obvious.
We hope so.
Yeah.
Yeah. Absolutely. Yeah. Okay. Okay.
Okay. Okay.
All right. Okay. Thank you.
He's camera shy.
Ken Leung. Actually, sorry, I haven't read the draft, so I'll say that ahead of time. So I shouldn't ask the question probably. I know that this says that you should get an IP address back. How do you deal with the IPv6 privacy aspect? So if you call again, technically you get the same IP address. Is that correct? Or if you want IP privacy, do you get a new one so that way, for
okay. This is a socket API, so it's about the interaction between the application and the TCP/IP stack in the host. So nothing goes out in that sense. Privacy is important for, this may trigger some communication like DHCP or RSRA. And if we need to deal with privacy, we need to deal with privacy over there. But here, there are no privacy issues.
So, because you do Slack, basically, right? So you're getting, let's say you did DHCP, you got /64 already, right? So now you're supposed to generate basically a random IPv6 address at that point. So I guess I wasn't sure if this would take care of that.
So there is another session about Slack later on, and maybe it should be relevant there.
So Krishnan, so Kent, like just to answer you, right? Like I understand your question. So, but the session continuity access and the privacy access are like orthogonal to each other.
That's true.
So there is RFC 5014, right, which lets you set different set of flags on there, whether you want like a permanent address or like a temporary address, like 4941 kind of address. So I'm not sure like how these two interact, right? Because are you going to like start merging in flags, and we might get like you want a permanent address, but with no session continuity or session continuity or private, it's not going to work, right? But maybe that's something worth calling out. But yeah, so I understood your question. That's why I'm answering. So 5014 is the way of choosing whether
5014 was about home address and care of address.
But it also has more in it. Like
I think it was mainly home.
I understand, but it's an API extension, and it actually talks about privacy addresses as well.
So
as I said, right, like it's multiple access and all the cross points don't make sense, right? So you cannot have session continuity. So you cannot use like a privacy address as a home address. It kind of defeats the purpose, right?
Right.
Okay. So what I'm saying is like there's like multiple access and all the values there don't make sense. So I think it's worth calling out here, saying like some of these things don't make sense with the other options. I think that's what Kent was confused about.
So I need to check the draft, because when we were using set socket opt, we had text that describes what happens if there's a conflict. But since I removed this feature from set socket opt, I don't remember if I left that text inside or not, so I have to check that.
Yeah, please do. Thanks.
Okay.
Thank you.
Last slide. Okay. Yeah, this one. Okay. So in the original versions of this draft, we had 3 types of session continuity: fixed, session lasting, and non-persistent. And that was quite, how will I say, similar to the work that is being done in 3GPP. 3GPP had another type of session continuity, SSC mode 3, which what it does is it tells the the network tells the host, you can receive this IP address. On the event of mobility, you can still use this address, but a limited time frame, and then you'll have to move to a new address. So we are not guaranteeing session continuity forever. We're guaranteeing that for a certain limited amount of time, and that gives you a graceful period to move to the new IP address. And I wasn't sure whether I want to introduce that here or not, but eventually I found a good use case for that, so I said, okay, let's add this too. And I'm not strong about that. If people object, I'll take it out. I think it's important to know that it will exist in 3GPP, so that's why I thought it would be good to have that here.
Well, I think I suggest we have this discussion in the mailing list and get some feedback.
Okay.
We'll try.
Yeah. Lorenzo, clearly, how's this different from a deprecated address? It's basically you just need to.
It's very similar to deprecated address. I think the small difference is that you get a note from the network saying this address is going to be deprecated, but you still have this amount of time before you have to take any action.
That's exactly what deprecated is.
Mm-hmm.
It is this address. Yep. Is going to go away at this number of seconds from now. That's exactly what deprecated means.
So are you saying you prefer the name deprecated to graceful replacement?
So, Krishnan, so I think what Lorenzo means is, like, I think he'll correct me if I'm wrong, is that you can already signal this in an array, right? So what you do is you set the valid lifetime to 0, okay, and preferred lifetime to something, which means that your stack will not select the address for any outgoing connections, but it'll keep all the connections that are already on. So what he's saying is this is not required. Am I right, Lorenzo?
Yeah. So here's the confusion. I understand that. The confusion here is that actually with these APIs, the application requests for this type of service. And for a long time, I didn't see why an application would want to request for such a service. And this is why I didn't add it to the APIs. If what you're describing is not a specific request from the application, you're saying, hey, the network supports that. It will give you an indication before that this address is deprecated, right? And by the way, if the application requests a session-lasting IP address and receives one from the network is not allowed to deprecate it, okay? Or the network guaranteed it won't deprecate it.
So what is the network requirement for graceful replacement?
If the application requests a graceful replacement address, it may deprecate the address.
I don't understand. So, okay. The only kind of thing we recommend in V6 is graceful replacement. So like no flash renumbering, right? So we always like deprecate the addresses because of V6. Like we can have multiple addresses on the same interface. So we always like gracefully deprecate. So we put the previous one into non-preferred but valid, right?
I'm not sure. I'm not sure. Why do you say always? Right now in cellular networks, you don't deprecate addresses. You received an address and it will continue.
I understand, right? So there's nothing in the cellular profile, right? Like the 7059, whatever, right? Like that, like, a bunch of us wrote together, which says this part of V6 is overridden over there, right? So there's like some things we say like, okay, we don't do like, NS, for example, right? Like, or RS, right? Like, and we just say like, we don't do it. So that specification says like where we are deviating from the IETF shoulds pretty much. Okay, so I'm not sure like what would be the network equivalent of saying I don't want graceful replacement. Like I don't see why somebody would say I don't want graceful replacement, right? Like, so that's the use case that's not clear to me. So why would an application come and say I don't want graceful replacement, and why would the network honor that? Like, what is the benefit? That's the part it's not clear.
Okay, let me try and answer that.
I think we need to take this offline. I think time-wise. Yeah.
Okay, so I'll respond to that on the list. Hopefully we will get that resolved and then we can go to work with Glasgow. Okay, thank you.
Thank you, Danny. So next steps, you're going to work offline and do on the list. Yeah, on the list. Yeah. Thank you, Danny.
So the next presentation is DMM deployment modules and architecture considerations. So who is the presenter?
Seal. Yeah.
All right. Okay. So hello, good morning. I'm Seljan, and also of this draft. As you know that this is a working group draft, and it is about the DMM deployment model, and which target high-level network architecture and deployment model where DMM solution would apply, right? So, and actually a couple of meetings before it became a working group document, when I recall. And now it is describing that the DMM terminology and functional element and the other. And also there are some mappings with the DMM function to the specific service primitives, that how DMM functions is associated with which service primitives, like mobility anchoring, and for example, like some MSH classifier. So this current version has addressed all the open issues, and now we think that now in a good shape. And but we couldn't get some much feedback from the working group and on the list. So another one important point is that, as you know, that here is that we are defined that the 4 major DMM function, so CPA, CPN, DPA, DPN. So based on this, that we try to, to specify and present it, that how it can be deployed, and some, DMM function can be combined together or separated, depending on that deployment model option flavor. So important thing is that we need to ensure that there is a consistency between this draft and with other working group draft. And so I hope that some author of each working group documents also is kindly, that check and is their definitions and terms are in the well consistency and with this draft. So now we are suggest moving this to AD review, and we are hoping to go by the next Singapore meeting. Okay, thanks. It is update of this deployment model working group document, and any comments and feedbacks will be welcomed.
Thank you. See?
Yeah.
All right. So that's.
I think we have the similar problem that there is no sufficient review, inside of this working group. So, I think maybe I suggest the authors to, offline to find some reviewers
sure.
and send their comments to the mailing list.
Yeah, but if it is, that available, that it would not be bad if we could have some, that who will be a volunteer, and if we could know that in this meeting that he can make them more straightforward. That
Yeah. So I'm not going to ask the volunteers again in this meeting time, but I strongly encourage you as the author to find volunteers, use this meeting time,
sure,
and to do the review and send the comments back to the mailing list.
Okay. Thank you.
Yeah.
Any comment?
Yeah, that's good. Thank you, sir.
Yeah.
So next.
Yeah, the next presentation is SRv6 for mobile user plan. Santoshi? Yeah.
Okay, just to set the context, there's a new proposal from Satoru-san. So yeah, go ahead.
This is Satoru Matsushima. I'm going to present some discussion of the applicability of SRv6. I'm not sure how many people are aware of what SRv6 is, but I'm talking about the SRv6 a little bit, and then how to apply SRv6 to the mobile user plan. Okay, so this slide shows just one example of the current mobile network deployment. I don't talk much about this itself, but several pain points there, such as the network is well fragmented to several parts of the road, and the session for mobile user or mobile terminal be handling for the session basis. That's really hectic operation required in the each of the mobile node. And we adopt the tunneling solution between the node of the mobile data plane. So it's not so much optimized in terms of the data path. So if we want to provide the optimized path for our customer, it's a little bit difficult. But it's possible, but it's a little bit costly in this architecture. So please, next slide. So this is what I think the idea, what if SRv6 become an alternative of the major tunneling protocol. So if we put the SRv6 header, extension header to the packet, the IPv6 network can integrate all of the network, not only for mobile user plane, but also the rest of the part of the network, the transport, metropolitan area, core network, not mobile core, but also the backbone layer of the network can be integrated, both of the with the mobile user plane network. And if the SRv6 ID, which is called segment ID, represent data plane role and function, it's enable us to deploying anywhere else within the SRv6 network. There's no need to put the specific role of the box or specific role of the instance in the specific place or the specific place of a topology. So that enables us to fully flexible to where to deploying specific user plane nodes such as S gateway, P gateway, LMA, or MAG, etc. So that's the benefit of the SRv6 when we achieve the that idea into our user plane network. Next slide, please. So I talk a little bit about SRv6 in a nutshell. SRv6 utilizes one of the extension header of the routing header. I think the person who sits in the room really aware of the routing header because the routing types header is really favorite. The SRH use it's not officially assigned, but using type 4 as ID of the header routing header type, and this header can include the multiple segment ID, which is the 128-bit space. So in terms of the routing header type 2, RA2 using just one segment, but SRH can include multiple, not only one segment ID to indicate the order of the segment. So that helps us to implement the source routing stuff. So SR segment routing define a bit more, but it's a really fundamental solution to achieve the source routing within the IPv6 only network. So please, next slide. So this slide shows how the packet goes through the SRv6 network. I make short this explanation. So packet goes through the left to right. Mobile node send the packet. It's assumed IPv6 packet. The access point puts the SR header. That includes the list of the segment which points the each of the mobile user frame function node. So in this case, we have segment B and C and D. D is actually a final destination, but the first segment is indicated by a segment left as a pointer, and then the access point node rewrites the destination header followed by the segment ID 2 pointed by a segment left, and then the node B receives the packet, and then the decrements the segment left, and then the rewrites the destination address by the SID that segment left point to the segment SRH. So node C, finally popped out the SR header, and then the figure of the packet is same with the original packet. So that's how SRv6 works. Okay, please next slide. So this is a little bit busy slide, but this is kind of the extended definition, which the SRv6 trying to standardize. So I think the original source routing is just kind of the source routing point to the midpoint of the path. But SRv6 network programming trying to introduce some semantics of this function for the segment ID. So we pick up the some segment SRv6 function from the whole list of the list. But at least here I picked up can be applicable to represent the mobile user, very typical mobile user frame function. So let me explain by using next slide. So it's a little bit tough slide still, but as I explained before, packet goes through the mobile node to outside network in uplink, and then packet go down to the mobile node in downlink side. So in uplink side, access node put the SR header into the customer packet, just in case the encapsulation is available. It's a little bit controversial agenda, but for make explanation ease, I use the insertion. So once the segment header, segment list inputted to the custom packet, the layer 2 anchor node, I define this terminology in this document, equivalent with the serving gateway, for example. And the anchor node processes the SR header and then rewrites the destination to the layer 3 anchor that's defined to equivalent with the packet gateway. Sorry. Okay.
No, it's not working.
Thank you. So that's the this notation means. And in downlink, layer 3 anchor node, for example, P gateway push the SR header to the packet, and then in the middle, layer 2 anchor nodes such as like S gateway process the segment, and then the forward to the packet to the access point, which is ID indicated, and then access node do the process of the kind of the cross connecting to the right place of the spectrum and time. So that's how the segment routing works for the mobile user plane. So that's what we have discussed in my draft. Okay. So nevertheless, SRv6 could be applicable for mobile data plane. Existing architecture has a huge footprint. It's really difficult to replace or update to new one. So they would be expected to have a big portion of the footprint. So what's the draft introduce how to interwork with the segment routing network is like this. We introduce a stateless interworking segment. Stateless is really handy to make the network easy to bandwidth decreasing, and also easy to introduce redundancy. So to do that, the idea is the existing network head address or ID in the packet that can be put to the 128-bit space that enable us to do the stateless operation between the existing network and SRv6 enabled network. So, sorry, this is showing the how the 128-bit consists of the ID from the existing IPv4 network. The locator of the interworking segment, followed by destination address of the existing site and source address of the existing site, and also tunnel ID, which identify the specific session. So that stateless mapping enable us for the stateless interworking. So now, if we success to introduce SRv6 in our network, the mobile function deployment is really flexible. So the how to handle the flexibility is could be another issue. So to deploying user plane function appropriately, we need some template to put the SID to right node for right row. So we can utilizing
You want me to forward the slides?
Yep.
Okay.
We can utilize FPC model to make a forwarding model and then configure our forwarding plane network adapt to the each of the tenant or slices. So that's the kind of the collaboration work with the DMM charter work item.
That's not working, Satoru-san.
Okay.
Just let me-
Okay. Sorry.
I made you believe it's working.
Thank you. So, okay. This is the one of the network slicing consideration with SRv6. So as I mentioned before, set of the segment ID can represent the network slice. So the set of the network resource can be aggregated by SID, which is very much same with the IPv6 numbering. So once we use the same prefix for those SID within the slice, that will be really handy to indicate the slice, specific slice. So then it will be, I'm not sure it's possible or not, but it will be one of the idea. Then the application in the mobile node can directly point the each of the slice by using SID in their packet. So that's the another possibility to handle the network, select the network slicing from the terminal side, even terminal, but also the application in the mobile node. Thank you.
Thank you, Satoru-san.
So, no. This summary. I'll skip the summary. Okay.
Yeah. If you want to move to a certain slice number.
Okay. Okay. Next slide, please. Okay, so this is next step. This is very premature work right now, but I want to study a lot more to cover the more user plane function to be supported by SRv6. So after this study, we will update the ID with the outcome with the study, and also the figure out the set of the SRv6 function for my user plane, which could be standardized. So the Spring Working Group trying to standardize SRv6 function, but if it be suitable, we can standardize the set of the SRv6 function to indicate or represent the specific mobile user plane function. And then collaboration with the other DMM working group item and other working group, Spring, for example, and as an operator vendor to work with that.
Not much time, but we'll take just one question. Yeah.
Okay. Simpon Wei from Huawei. Thank you for your presentation. I have a question. As my understanding, you want to use the segment routing to do mobility measurement, right?
In data plane, yes.
And how if you use this for mobility management, whether the IP prefix types defined in on-demand mobility will be needed or not?
I'm sorry.
Because there have been a list of different type of prefix defined in on-demand mobility draft.
Mm-hmm.
So if we use this segment routing, do we still need the different type of IP prefix?
I don't think it's the SRv6 SID assignment is binding to the terminal IP address, because the SID is SID to indicate the midpoint of the path or specific set of the resource. It's a little bit decoupled.
Okay, thank you.
Yeah, this is more about optimized routing. That's more about address selection here. Yeah, Mark.
Marco Liebsch. A brief clarifying question. I think you addressed it in the slides, but I didn't get it right. So in today's network, it runs as an overlay of mobility anchors and chain. So taking these anchors, do you think about using segment routes to define the hops between these anchors, or do you consider having way more hops given in the segment route to find more fine granular steering and customized steering?
Yeah. Right. Not only for the mobile user plane function, but also other use cases already available to integrate the optimize the path or other network function.
How many hops do you think about specifying? Is it 2 like today or way more?
Depends on the each of the operator's policy.
And if you take it as replacement of today's tunneling, there is some information about QS and whatever.
Yeah.
Is this based in segment routes in the routing header to incorporate such information like QCIs or?
Yeah. I didn't mention my idea in this slide, but I wrote a draft to put some semantics of the QoS or rate limiting stuff that can be combined within the function segment, which combine within the 128-bit space. That's really handy to put many of semantics in that large bit space. So so if we define the segment ID multiple, but that can be, pushed into this one of the 128-bit space that can be using masking something.
I'm curious. Let's discuss offline.
Okay. Yeah. Sorry.
It's running out of time, but I have a very short question. Is there any advantage compared to other routing-based solution discussed in DMM? For example, there was a BGP-based solution and other routing-based solution.
BGP-based solutions still just using the tunneling or some flow-based hop-by-hop solution to manipulate the path, but this SRv6 idea enable us to much more aggregated operation without any of the tunneling.
Right. Thank you, Satoru-san. I think a couple of things. This is a very good, document. I think at least a good work item. Currently, it's not in the charter, but fairly it's new work and no discussions, and we'll let authors do some more work, also get some feedback from the working group. We'll discuss with the AD if there's sufficient interest to take this up. We'll definitely do that.
I hope I can update to propose the working group item or not with when I got a good traction with the working group or industrial community.
Right. But definitely it's very good work item that hopefully we'll take it up. Yeah. Thank you, Satoru. So next is Carlos on network-based and client-based DM solutions using mobile IP mechanisms. So Carlos, unfortunately, we had to cut down your time a little bit. Hope you'll be okay with that.
Okay, so I'll try to be brief, although I have a lot of slides, but I'll try to go fast.
Yeah.
So this is a presentation about some drafts that have been there for a while. As you will see, we had implementations back in 2013 and 14. So next slide, please. So I'm gonna just discuss about a client mobile IP-based solution that we specified some years ago, and the same for network-based DMM solution, and an additional item for network-based solutions, which is what we call the distributed logical interface. So next slide, please. So motivation. I think we have been working in this working group for a while on the 4 main charter items, but I still think that it may be good to discuss on solutions based on well-understood protocols like mobile IP and proxy mobile IP. There have been a lot of proposals out there. Those that I am presenting here are the ones that we work on, but there are similar alternatives, and I think that maybe now the good time to see whether there is interest in specifying this kind of mobile IP, proxy mobile IP-based solutions for DMM. Next one, please. So well, those are just pointers for the drafts and some academic papers. We have we work on that quite extensively in the last few years. So there are plenty of academic papers with more details and performance analysis, discussion on deployment, this kind of thing. So I will skip just for the sake of timing. Next one, please. So let's go into the brief summary of the client-based DMM solution. So it's basically an extension of mobile IP with some very simple consideration also for how to make that more deployable or easy to deploy. So basically what we do is to propose moving the home agent to the edge. So basically we are collocating the functionality of the home agent on basically the access router, as we will see later. Next one, please. Then we call that distributed access router, but well, terminology, we have been playing around with that, so you can call distributed access router, distributed gateway. It's basically the same thing. It's the access router with anchoring functionality, as also Anthony was discussing previously. So that access router, that home agent will assign topologically valid IP prefixes to the attaching mobile nodes. So an attaching mobile node gets an IP prefix, configures an IP address, that can be used for the time the guy is attached there. And then if the mobile node moves to another access router, to another distributed access router, that guy will obtain a new address topologically valid on that access router, but it will be able to still use the IP address that it obtained while visiting the previous access router. So, and in that case, that access router will play the role or will function as a home agent. Next one. Just see that in a very simple diagram. So first attachment, mobile node gets an IP address here. You can call that care of address, but at this point in time is the IP address the only one that the guy has and is topologically valid here, so it can be used to connect to any node in the internet. If the guy then moves to another access router, it will obtain a new address here that can be used for new communications directly with any node without any tunneling, but that can be used also as a care of address to still use the address that was configured here. So for sessions that are ongoing while the guy moved, this will be used in the tunnel with the previous access router to communicate with any existing node that has a communication ongoing. And for new communications, he can use the address configured on the new access point of attachment. Next slide, please. So here you can see that specifically. You see that for CN1, we use the previous home address, let's call that way. And for the new communications with CN2, for example, we just use the topologically more optimal address that was assigned by the access router 2. And we can continue with the example just back for a minute, sorry. If we move again, we can configure a new address and the same thing can go on, of course, as long as the sessions stop being alive for all assigned addresses, those can be just removed and stop being used. Next one, please. Next one. Okay, so that was a very brief summary of the client base, so very simple extension to mobile Ipv6. Then we also did the same for network-based mobility management. So we just extend Proxy Mobile Ipv6. Again, we push the anchoring to the edge at the access router level. And we came up here with a partially distributed solution in the sense that we have a data plane distributed, but the control plane centralized in a kind of control-only LMA role, which is what we call CMD, as we will see in the next slide. Next one, please. So again, you can forget about terminology because we are using different terminology because that was a different draft. Again, we have a distributed gateway access router that is the access router where the mobile node attached to. And this guy, in this case, concentrates the access router functionality, the LMA, and the MAC functionality. Because, again, it will be delegating prefixes to the mobile node that will be optimal because are topologically valid there. But then if the guy moves, the guy will obtain new addresses at that location and will be able still to use the previously allocated addresses. So in that case, those as a router will be playing the role of MAC and LMA depending on the different addresses. We have some additional terminology. We're not going into the details because I think it's easier to just see in an example without going into much into all the terminology. And the only thing I wanted to highlight here is that we have this central mobility database, which is this control-only LMA that stores the different allocations of the prefixes and the location of the mobile nodes. Next one, please. So here, just an example. We have these two guys. We have the database control plane here. So if a mobile node attaches to one of these access routers, it will obtain a prefix topologically valid here that can be used for communication with the internet without any tunneling. At the same time, the guy here will communicate that mapping or that allocation of prefix with the mobile node to this central mobility database that will know then the mapping of the address of the mobile node and the location. So if the guy moves, next slide, please. Basically, well, here we explain that there are different ways of updating this database, different operational modes. Conceptually are similar, but we are going to focus for the sake of time also because it's the one that we implemented first, what we call the proxy mode. So next one, please. So continue with the example that I think is easier. If the guy moves, the mobile node moves, the guy will obtain a new address at the same as before, topologically anchored at the new access router, but the mobile access router 2 will also communicate that movement to the CMD that since he has the knowledge, the mapping of the previous address that was being used, it will take care of sending a signaling message to the previous one and also to the new attaching access router to establish a tunnel between the two access routers. Basically, like this is the LMA for the previous prefix, this is the MAC, and we have a tunnel. The way the signaling is done in the proxy mode is basically this guy signals to this guy, and this guy will reply back. You know that there is a prefix being used on this guy, so you have to establish a tunnel, and this guy will signal the same to this guy, so the tunnel can be established. From the point of view of the data communications already established will go through this tunnel between the two access router. New communications will directly go without any tunneling between the node, the router, and the internet. So basically, it's applying proximal IP with some signaling to enable that. Next one, please. And then another piece of that solution that is independent can be used or not, but I provide some advantages is what we call the distributed logical interface. So basically what we allow is to configure logical interfaces on the access routers. So when the mobile node moves, it doesn't see any change because it will always be connected to the same logical interface from the point of view of the router. So if the guy moves from one gateway router to another one, this logical interface will be constructed, set up on the new distributed gateway, so we will see the same MAC address, the same IP address as in proximal IP, but with additional advantages because we can have different logical interfaces. So it's like the guy, as it moves, it will be connected to new routers, but still seeing the old ones, and that allows to play with prefix-specific routes and these kind of things that with just plain proximal IPv6 you cannot do it.
Carlos, can we?
Yeah, that's.
So I think next steps we'll discuss in the. My apologies, but unfortunately. So we'll discuss this in the mailing list.
Come on, previous one at least.
Okay.
That one. No, the one before. Okay. That one.
Sure.
So I was to jump, and we are losing more time on this than I was planning to actually. So there are more details on the distributed logical interface on the other slides, and I just wanted to highlight that we had demos already in IETF in 2012 and 2013. The code is available. Next one on is open source, so you can download the code for the client base, the DMM, the network base. And even though I didn't cover here, we even have an NSDN solution. Also, the code is also available there. So next one. So in terms of next steps, just a question for the working group, whether you think it's useful to continue working on this or not. That's basically what we wanted to know. We are willing to continue working on this if the working group thinks that is useful to do so.
Okay, thank you. So I think we'll follow up on the mailing list. Yeah. I think next is Xingpeng Jackie V, anchorless mobility.
Hello, everyone. The purpose of this presentation is we want to give a scenario to the work group and some of our proposals and see if they are interested on this. Multi-access edge computing. We say it MEC syncs computing and storage capacity to the edge of the network and use the virtualization platform for running applications. MEC could be a candidate's choice to increase traffic throughput and reduce the end-to-end latency. MC, as I have said, MC can be used to reduce the end-to-end latency, and but for some scenarios, for example, the critical low latency requirements, the deployment of application instance as the agile network may be not enough to satisfy this critical latency. So when the mobile node moves away in the network and to guarantee the low latency requirements, we can migrate the application instance between the MEC servers, which is following mobile nodes movement. And in ETSS specification, we call this smart relocation. Here is an example. When the mobile node moves away, the application instance will migrate from the previous MEC server to the new MEC server. And here is what DMM could do for MEC smart relocation. We want to propose a network-based solution in DMM workgroup to satisfy the service community in this MEC scenario. There is a gap for the current DMM solution. In the on-demand mobility scheme, the routing redundancy can be reduced at a certain level, but it's not quite enough for the MEC smart relocation scenario, because for the ongoing session, the on-demand scheme couldn't eliminate routing redundancy at the same time providing service continuity. And here is our proposal solution. And honestly, our solution borrowed the concept of the identity and the locator separation concept. We define a network location independent host ID to identify the communication session, and the ID will be assigned by the network to the host, and it will remain unchanged during the movement of the mobile node. And the traffic will be still routed on the IP address which is based on the network location information. Here is an example. When the mobile node and the application instance both have their own ID, which is IDMN and IDYM. When the mobile node moves to the new location, the application instance will be migrated to the new location. And here is there are three paths. The black line is the path before the VM migration, and the blue one is the path during the VM migration. And after the VM migration has been finished, the path will be switched to the red one. So using this method, we think the latency can be reduced for this latency critical application. Okay, I think that's all. Thank you.
Okay, thank you. So this is a new work item, right? Yeah, Kent. Yeah, quick. Yeah, no, that's fine. Yeah, go ahead.
Kent Liang. Just wondering, have you looked at Lisp?
Yeah, Lisp.
Because I mean, it sounds like what you're doing here is basically an ID locator separation, right? So that way you can move and maintain the same.
Yeah, there are several proposals based on the ID locator separation, and I'm not sure whether this could be a candidate protocol or not, but maybe we will do some evaluation on that. Yeah, thank you.
Okay. So this is a new ID, right? There haven't been any discussions, right? It's you posted the document.
Yeah.
Okay. So hopefully, folks can review and provide feedback. Next, we have the last topic. Actually, I think we are time-wise, we are okay. I think we just rushed up Carlos. So sorry about that. Yeah. Bad time management. Yeah. Yeah. Okay. Yeah, I think we gained it. Okay. Next is this is the router advertisement prefix option. Wuching. Yeah. Okay, here the problem. There's the PDF. Okay.
All right, so you can go to the next slide. All right. In Chicago, we had talked about having router advertisement and router solicitation in support of 3GPP SSC modes. This would be a single example. And after the discussion, we had a pretty in-depth discussion with Suresh and Sri, and we came to some enlightenment about router advertisements. So we're kind of continuing along this line. Next slide, please. And the example use case here is, and I have the wrong slide here, but for 3GPP, one of the things that they have in this TR23799 document, issue 6 describes the need for different SSC modes. Specifically, there's these 3 types of SSC modes, and they map fairly well to the on-demand mobility work that's ongoing in this working group. Next slide. And so, what is needed from the network perspective is the ability to express types of continuity service that's associated with a prefix. There's 3 that are currently described, and Danny added this graceful replacement in the latest version. So we're looking at providing session-lasting IP addresses, fixed IP addresses, non-persistent, and then this graceful replacement. And so what we're looking for is a way for the ability of a mobile host to select the appropriate IP prefix from an RA. Next slide, please. And so in order to add on-demand to RA, there are a number of ways it exists. We started off with thinking about modifying RA itself to create a vendor-specific option, and after hearing all the war stories and scars from Suresh, we decided this is probably not a good way to go. And then we started looking at, well, what are the actual things we need to get done, and what are the right ways to do this? And ultimately, we came to the decision that the bottom 2 ways are kind of the ways we can handle this. One is creating something at the prefix option level. And so, the prefix option gives you, for a specific prefix, various options that you can use. And we decided that it might be useful to do this in the prefix option itself. The only drawback there is that it would require the modification of reserved fields. So if we create a prefix option that's kind of alongside the prefix option, it feels like it's at the wrong level, but slightly cleaner. But if we put it inside the prefix option itself, then we need to modify one of the reserved fields to specify the prefix type. So this is kind of where we are now, and one of these options will most likely need to be considered in order to provide the different SSC mode specifications in RA. Next slide. So we're here to see if there's any interest in continuing this work. We've written a draft that's referenced here. If you would like to take a look at it and either contact myself or Danny, we'd be happy to talk to you. And I think that's it.
Yeah, Michael.
Okay, Michael Abramson. So me and Eric Klein, we have a draft that's talking about the X bit, which I guess there was some coordination because you're not stomping on that one, which is a good thing.
Yeah.
I think you should bring this to 6-man.
Right.
And, oh, okay.
Right,
Because
right.
I think that,
right, Danny was at the 6-man and we had...
Oh,
yes.
Monday morning. Okay.
Yes, so...
No. There is no conflict.
Yes.
But I don't think it's good. We're not stomping. But there is the whole R bit that is not in your draft. So there is actually an RFC that's defining one of those that is reserved in yours.
Okay.
So, but right now there's no problem. I just think that there's, if we take our proposal and your proposal, now there's one bit left. So I think 6-man should make a decision.
Right.
Is this?
Absolutely.
Should we burn the bits for this or not?
Right.
Right.
And yes, we are happy to talk with you. And yeah, we need to follow.
Suresh Krishnan, irresponsible AD. No. Anyway, so like these bits are not gone. So we did define an extension mechanism for the flags, right? And so we can do like a extension mechanism for this with the last bit, right? If we are worried about it. And we've been kind of inconsistent with like how we use updates in the IETF. So it's not specific to like int area or anything, but generally we don't have a consistent definition of updates on anything. So I think that would be one way. The other way would be a registry, but like I do believe we need to closely track this because I have seen these errors happen too often, and it's usually caught by somebody who's vigilant, not by anything that's general in process. So I found a few of these mistakes where somebody is using the same bit for different things, and so like I just like say if I notice it, but I'm not going to notice all the drafts. But I do think we need like a more rigorous way of doing this. So like Michael has raised it for something else, but I think it's like similar. Like we need to do this for like most of the bit options and everything.
I agree.
Alex Petrescu. So a couple of questions here. I noticed it is called a on-demand option in arrays, something like that.
Yeah.
Who demands?
Oh, so this is just the terminology that.
I think Alex is saying we are not changing RS. So
yes.
Who demands and how does the network know?
So maybe we want an option in router solicitation.
Well, this is more of a I would guess a religious battle.
No, yeah, okay.
Right.
So.
I mean, really, the only thing RS is meant to do is just to ping the network to get, a router advertisement.
Yes.
Thing. So it doesn't quite mesh well, but we don't really want to change the semantics for RS. I think that would be a very long.
Okay, and the answer, the documentation, the answer in this router advertisement would be something like, this is one of the 4 types that you mentioned, or the third or
so the basic
type.
idea is the RA would contain these various options.
This option.
Yeah, it's not necessarily on demand. I agree.
Okay. Yeah. Okay.
I think
I just want to add to what you said as a response.
Danny Moses.
Danny. Yeah, you're right. This is not the perfect solution because in this solution, there is no entity who asks the network for something. And in this solution, we assume that the network will provide different alternatives, and at least the application can choose one of the alternatives. If we want to provide the application a way of really choosing or expressing what it chooses, DHCP is probably the only alternative. Having
understanding that we will not be able to modify RS. So that's another response for you.
Yeah, thank you, Danny. Alex, I think let's take it offline. Yeah, quick question, Eric. Yeah.
Oh, I think I echo some concern about consuming the bit spaces. This should probably come to 6-man if you want to. But also, like, there's no saying that we can't modify RS if there's some way to frame the argument, right? To say,
Don't touch RS.
Yeah.
So we said, okay.
Yeah.
okay, that might be the outcome of going to 6-man with that, but it's
Yes.
not. But okay, I guess that was already all right.
Yeah.
Oh, the one last thing I wanted to say was there's a way in which I think actually PVD would be the best solution for this. If you had a separate array with a different PVD that says this is a long lifetime PVD or whatever the characteristics are, with just a PIO inside.
One of the option in PVD makes
That
sense.
would be
yeah.
that would be good. And in fact, that RA could move as the network moves, and the other things around it. I think PVD would be better.
I'll talk to you offline.
Thank you.
Let's move on to the last presentation is virtual CPE deployment considerations.
Sorry. So I looked at this draft quickly, and this is something we have actually implemented using forces in the past. So it was an easy fit. I put these slides quickly. So quick, maybe just jump to the next slide, right? So in forces, you have a data model. I'm assuming that this draft is, you have an information model, but you also have some reason you also define Yang models in there. So is Yang, have you decided on Yang as the only data model, or? No, so there is an information model. So in forces, you have a data model, which is an object-oriented definition of resources. At the bottom, you have the resources used. Forces was originally defined just for data path control. However, you can define any resources you want. We constantly use Linux resources. Anything is defined as /proc, etc. Write a document for it, and we start talking to it. So from the data model document, you can define an interface for applications. So applications is a very simple protocol with a handful of protocol verbs: set, get, delete. You can publish events, subscribe to events. And so where the application sits is equivalent to in the PFC model where the mobility controller will sit. And you have distributed controllers which talk to distributed resources. High availability is built in. And how do I change this? Oh, there. So the protocol semantics are very simple. Like I said, it's not an RPC based. Well, the RPC in the sense that there's only a few verbs, infinite amount of nouns which look like URIs, designed for very high throughput. So binary encoding, which is formally defined in the data model, traffic sensitivity, optional high availability, both of the controller and the data path. Next one. Protocol semantics, very simple. Publish, subscribe is built in, as well as request response. Next. An LFP class, like I said, is object-oriented. You can build a base model and then inherit from it. When you instantiate these objects in the resource path, you can have instances of them. So good fit for multi-tenancy. We always put multiple containers, each with its own LFP class instance of the same resource. Next. Just keep going all the way to the end, I think. Go to the last slide. Okay, so there's a very good fit with DMM because we already have defined the data path and control separation. There's the information model. When I took a quick look, they're not exactly one-to-one mapping, but there's very close mapping to what we have already implemented. And the protocol semantics have a good fit. A slide. So there's interest. We'll come back again.
Okay. Thank you, Jamal. Any questions for Jamal?
Albert Sprint. My group actually has the primary open source implementation for Open Daylight, so the FPC agents. Just my general comment. Right now, we're using an agent heavily to get more benefits of common provisioning other items. With respect to forces, is it something that fits well with the agent model, or is it very much something that sits very much on the data plane node itself between a client and data plane?
So the controller, if you go back to the big picture diagram there, there's one diagram, yeah, there. So the resources controllers, essentially, these are things you talk to us, and you send messages to the data path, which has an agent. So the two ellipses constitute a multitude of agents, basically.
Okay. So you're proposing this potentially from a very myopic controller point of view. You're proposing this for both the northbound and southbound, or just
could be both.
South?
Right now we use it for both. As you can see, the interfaces are in two places, but it could fit in the second. So there's two interfaces, right?
Yeah.
This could be like a northbound, but there's a southbound right there.
Okay. Well, just my general observation, right, as an implementer, right, we used Yang just because we were using off-the-shelf controllers. I mean, it's there. There's lots of tools.
Okay.
That being said, right, we constantly struggle with lots of things with throughput, not because of Yang, but because Java OSGI. We're indifferent to the southbound protocols in general, I think. But speaking, wearing my hat as an FPC co-author, I would say we're still focused on the information model and not as concerned about the over-the-wire rendering at this moment, right? So I think it's important, at least for the authors, to get the information model out. So I wouldn't preclude this. It definitely is something we need to evaluate, from an author perspective, and I'd also be interested, just as an implementer, in looking and have some more questions offline as well.
So we can talk offline.
Absolutely.
So we've implemented this with Linux.
Yeah.
With offloads and things like that. So.
Great. Excellent. Nice work.
Okay. Thank you. So with that, I think probably, Jamal, we can have some discussions in the mailing list. You don't have a draft, right? This is just a proposal at this point. If there is sufficient interest, maybe we can do that.
Okay, so there's interest or no interest? Yeah, you're interested. Okay.
With that, we are ending this session. Thank you so much. And thank you, Michael, for the Jabber notes. And Danny, you have taken the notes, right? Meeting minutes. Live. Okay. Thank you. Thank you.
Thank you.
So I'm available for lunch if you want.
I think Viraj team card or something.
Yeah.
Right?